I'm Jacob Nielsen, and me and my partners Jake Neely and Matt Stevens are working on the balance beam. Our project is to control the position of the ball by changing the slope of our ramp to get to go to a set point, which we control through the use of our PID controller. The main parts of our project that we're able to control the set point or control the ball is through our sensor, our actuator, and our controller.
So as we can see from here, we're using a sonar proximity sensor to determine the position of the ball along the beam, and every fraction of a second this position will then be grabbed by our Arduino Uno chip, which is our controller. And this controller will then communicate between the servo motor and our PID controller to determine what slope the ramp needs to be at in order to adjust for the position of the ball to hit the set point.
We used the Arduino interface to generate and implement our PID controller. Under the Tools tab and the option Manage Libraries, we were able to add a library called PID v1. This library works similar to the package SimplePID that we used with Python. It contains the PID equation and saved us the trouble of solving this equation manually. We began our code by defining our tuning parameters and several other variables that we would use in conjunction with our PID calculations. The first step in our controller was to calculate an input for the PID calculation. This loop read position uses the sonar sensor to determine the location of the ball. It does this by emitting a high-frequency ultrasonic sound wave and then measures the elapsed time until it hears an echo. Using the speed of sound, we can convert this time into a distance in centimeters. This calculated distance serves as the input for our PID controller. We give the controller a set point, and the package calculates an output. This output is fed through the Arduino to the servo motor, which tells it what angle it should move to, what angle the beam should be at in order to control the position of the ball. We set some minor limitations on the position of the servo so that the output of the controller was always possible for the servo motor to achieve.
The biggest problem that we had with our design was the sonar sensor. Because the ping pong ball is relatively small and has a curved face, it made recording accurate measurements relatively difficult. The maximum allowable length that we allowed the sensor to record was the length of the rail, 35 centimeters. Interference was causing the sensor to record one accurate measurement at, let's say, 10 centimeters, and then the next measurement would come in at the full scale of 35 centimeters. So the controller was trying to respond to an accurate measurement of 10 centimeters and then to an inaccurate measurement of 35 centimeters, and every other data point would come in like that. So what we were seeing was big fluctuations between tilting down to try and move the ball to the set point and tilting up to try and keep it from falling off the edge, although it was in the same place the whole time.